On Monday morning at 8:30, we'll meet and start the next phase of the class. Our meeting place will be at Fants Grove. This is a few miles south of campus, and up here, this is campus here, and there are the bottoms. There's a well field at the bottoms, and this is Route 76. So you head south on 76, and you'll cross over 18 Mile Creek right here. So you go downhill and you'll come up a fairly long hill. This is Tri-County Tech, and there's a stoplight right here. So if you take a right here, it's Fants Grove Road or Woodburn Road. Go down that road, and where it crosses the creek again, right here, this is the area where we'll be working. Our base will be on the other side of the creek here. Turn in a gate and come in right there. We'll have a van leaving from campus at 8:15, I think, something like that. We'll give you more details about that later. And so to get started, I'd like to give you a little bit of an overview. Well, actually, let me just first point out for scale, from here to here is about 3 miles. If you drive it and you come from Brackett Hall and have to go on the roads here, it's about 5 miles according to Google Earth. So just to give you an idea about where we are. So yeah, here's another view of it. We're going to meet right there. And so here's the big picture. This is Lake Hartwell here and Lake Kiwi. 18 Mile Creek that I just pointed out, and Clemson is right here. So our field site is right in here. This red dot here that shows up on the National Atlas, this is the gauging station on 18 Mile Creek. It's a stream gauging station, and so we can get a reading of the flow rate in 18 Mile Creek just upstream from our study area. And if we zoom in, here's the gauging station. We'll show you that later. This is Clemson. It's about 10 miles from here down to the lake by Anderson, just for scale. And here's 76, and the area where we'll be working is, well, I guess we're going to have one field just a little bit upstream from 76, and then a couple fields downstream. So we're right in there. So this is the geologic map of the area. You can see Clemson is right there. Anderson is down here. Here's the lake by Anderson that I just showed you. So 10 miles from here to the lake along that path for scale. And you can see the structural grain north 30 east roughly. And you can see also that these are folds. So this is the axis of a syncline. There's the symbol for syncline, 2 arrows pointing in. And here's another syncline axis. And in between, this is the overturned anticline. And here's the axis of the overturned anticline. And you can see from this one here that it's plunging. So that's the structure. These are high-grade metamorphic rocks. And if we zoom in on the 18 Mile Creek area, right in here, we see this is the axis of that fold, this red line right here. It's kind of hard to see my writing. And the yellow is the alluvium along 18 Mile Creek. The pattern here, this crosshatch orangish color, is a biotite granitoid or a granitoid gneiss. That's how it's mapped. And up here in Clemson, the region is underlain by a biotite gneiss. And right here, this is the area where we're working, and you can see structurally that it's got this syncline going through it, and we have this biotite gneiss kind of wrapping around like that and underlying part of 18 Mile Creek. So there'll be few outcrops that we'll be able to see, and we'll keep this map in mind when we look at them. So we zoom out and get a little bit different perspective on Lake Hartwell, this syncline, and here is this overturned anticline. So the area where we're going to be working consists of the alluvial system around 18 Mile Creek. And I've highlighted 18 Mile Creek here with this colored line that I drew on this perspective view from the air. This is Tri-County right here, and so as you drive out, this is 76, and so you cross 18 Mile Creek right here. And as you cross it, you may see, look to the right and left, and you'll see these fields. So to get access, you'll come down this road. This is the Pendleton waste treatment plant, and then you'll cross, and we'll be meeting right in here. The fields where we'll be working are these agricultural fields right here. And we'll also be considering some of the upland areas around them. These fields are alluvium, and we'll also be interested in the upland area above the alluvial system. One thing too you might notice is that this field kind of necks in. So right here, this is the bedrock, and it also necks right in here. And the bridge is built in this area where the bedrock is forming a fairly narrow gap of alluvium. The ground is just more stable there. Okay, so that's another overview, and what we'll be doing is breaking into groups and characterizing this area as groups, and everybody will have their own area. There'll be a bit of overlap, so some areas will be shared between groups, and you can work out some arrangements with your neighbors to share data. And this is the arrangement of the real estate. This field down here, this is the waste treatment plant, and this field down here has been having some problems with wild hogs, and there are traps set in there, so they don't want us to access that field. So we'll be working in these other areas.